This chapter covers several electrolytes and maintaining balance of them. Right here, we're going to focus on sodium and potassium. So sodium, both of these have several responsibilities. We're just going to look at the main one. The main thing that sodium is responsible for is your osmolarity. Sodium has the biggest impact on the water in your body. So if you have hyper, too much sodium, and remember it goes by its Latin name, so this would be hypernatremia. Your blood would be too salty. Your extracellular fluids. So remember, your blood and your interstitial fluid pretty much stay equal to each other with the exception of protein. So your extracellular fluid would be too salty. So this would draw water out of your cells. And you would get crenation of your cells. If you don't have enough, that would be hyponatremia. This would mean that your extracellular fluid is too diluted. There's not enough salt. And this would cause water to enter your cells. And you would get lysis, and your brain would swell. If we look at potassium, potassium has several responsibilities. One of the main ones is to repolarize your heart so that it can beat again. So think back to chapter 19. You had that cycle, -60. Opens the sodium gates, sodium comes in, you go to -40, this causes calcium to come in, you go to 0, this causes potassium gates to open, potassium goes out, and you return to -60. Potassium is what repolarizes your heart. And this is what keeps it beating. If you have too much, that is hyperkalemia. So think about this, how that's going to affect the heartbeat. If there is too much potassium out in your blood. So remember, the potassium moves out by diffusion, which means you move from high concentration to low concentration. Well, if you have extra outside, then it's not going to diffuse out. You have to have the inside be the area of high concentration and the outside be the area of low concentration in order to get it to diffuse out. If you put extra on the outside, you stop that diffusion. You no longer have that high and low concentration areas. So hyperkalemia will stop the potassium from diffusing out of the heart. So now, because it's not diffusing out, your heart fails to repolarize. So you won't go back down to -60. So this means your heart just stops beating. If it doesn't repolarize, it doesn't beat the next time. So you have cardiac arrest. Okay, then let's look at hypokalemia. If you have hypokalemia, you lack potassium out here. Okay, so again, think about diffusion. This is inside is going to be your area of high concentration. Now outside is going to be very low. Remember, diffusion stops once it's equal. So if you lack potassium on the outside, even more is going to diffuse out. So you're going to have too much potassium diffuse out of the heart. So that's going to hyperpolarize. The more potassium diffuses out, the lower the voltage goes. So this will cause you to hyperpolarize the heart. So instead of -60, maybe it's -70. And when you hyperpolarize it, you make it so that the sodium can't get it up to -40. It's so negative, you let sodium in, but you don't quite reach -40. And if you don't reach -40, you're not going to open the calcium gates and the heartbeat is going to stop. So you hyperpolarized the heart so low that sodium can't raise it to -40. Maybe the sodium only raises it to -30 now, which isn't enough to open the calcium gates. And so again, cardiac arrest. So when it comes to potassium, either way, if you have too much or not enough, your heart stops beating. Okay, so then if we think about potassium injections, if you get too much potassium, somebody injects potassium into your blood, that is going to stop the diffusion of potassium out of the heart, and the heart will fail to repolarize and you will have cardiac arrest. Well, there's two ways we use this. This is how we execute criminals. Right? So lethal injection, it's a shot of potassium. Also, veterinarians use this when they put animals down. So like if your dog is old and sick and you take him to the vet to have the vet put him to sleep, they give him a shot of potassium. Okay, insulin is going to affect your potassium. Remember, the whole point of insulin is that it moves nutrients from your blood into your cells. You get insulin after you eat. Well, potassium is one of those nutrients. So before in chapter 17, we talked about glucose and amino acids and lipids. It's also potassium. So every time you have insulin, potassium moves out of your blood and into your cells. So insulin has the effect of reducing potassium. So if you overdose on insulin, so this would be like someone who's diabetic and has to take insulin shots, it's very important to give them the right dose. If you mess up and you give them too much, so if you overdose on insulin, you will move too much potassium out of the blood. And this will cause hypokalemia. So then, because there's not enough potassium in the blood, too much diffuses out of the heart, and that makes the heart hyperpolarize, and the sodium can't raise it to -40, and you get cardiac arrest. And sometimes in the movies or TV shows, they'll kill somebody by giving them a shot of insulin. There's the movie The Accountant. It's a really good movie. And in that movie, the bad guys kill a guy because he's diabetic, and they break into his house at night and give him a shot of his own insulin, and he has a heart attack and dies. Okay, bodybuilders have to be careful of this. Remember, insulin moves all of the nutrients from your blood into your cells. And if you remember back to chapter 17, one of the things insulin does is it moves amino acids into your muscles and stimulates protein anabolism. So insulin makes your muscles bigger. So insulin moves amino acids into muscles and stimulates protein anabolism. So just look back to chapter 17 for that. This makes muscles bigger and stronger. So sometimes competitive bodybuilders will purposely inject themselves with insulin to help make their muscles get bigger. But this can backfire. It can be deadly because it can cause that hypokalemia. And that hypokalemia can cause cardiac arrest. Okay, pH is another important one. One of the biggest dangers of low blood pH is that it will affect your potassium and cause cardiac arrest. So let's look at how that happens. So you have your cell and you have your blood. So if you have low pH, that means there's extra hydrogen. So remember, a drop in pH means you have too many hydrogens. So that means we have a lot of hydrogen here in the blood. So the hydrogen is going to diffuse. You create a high concentration of hydrogen in the blood. So some of that hydrogen will diffuse into the cell where there is a low concentration of hydrogen. Now you also have potassium in your cell. Potassium and hydrogen are both positive. They're both cations. And remember, likes repel. So as all this hydrogen is diffusing into the cell, the potassium doesn't like it. It is repelled by all these other cations. So the potassium will leave the cell to get away from the hydrogens that are coming in. This causes then extra potassium in the blood. You get hyperkalemia. And if you have hyperkalemia, go back up here, if there's extra potassium in the blood, it won't diffuse out of the heart, your heart fails to repolarize, and you have cardiac arrest. So before you've learned about how changes in blood pH are dangerous because they can denature your proteins, now you know a second way that changes in blood pH are dangerous. So there's two things about blood pH that can kill you. One is it can denature your proteins. The other is that the hydrogen will diffuse into your cell, which drives the potassium out of your cell, which causes hyperkalemia in the blood, which makes the heart fail to repolarize, which causes cardiac arrest. Now we can move on and review some hormones. So this is all a review of what you've already learned in chapter 20. So first we're going to look at the renin-angiotensin system. So remember, you have your liver makes angiotensinogen. So this is an inactive hormone that is made by your liver and it is kept in your blood all the time. So you always have angiotensinogen in your blood. Your kidney is in charge of activating it. Your kidney is monitoring your blood pressure. and it will detect when you have a drop in blood pressure. So if your blood pressure gets too low, your kidney's going to know. Also, your kidney responds to norepinephrine. So if you have an adrenaline rush, your kidney's going to know about that also. Either one, a drop in blood pressure or norepinephrine, will cause the kidney to secrete renin. Renin is an enzyme. And renin converts angiotensinogen to angiotensin 1. Think of angiotensinogen like a can of SpaghettiOs. It's sitting in your kitchen cabinet. It's just there waiting for when you need it. It's inactive. Renin is the can opener. When you need your SpaghettiOs, it's time to eat lunch, you have to get your can opener out to open that can and access your SpaghettiOs. So renin is the enzyme that converts angiotensinogen to angiotensin 1. Okay, now hopefully you're not just going to eat cold SpaghettiOs straight out of the can. You're going to put them in the microwave and warm them up. So we have another step here. Angiotensin 1 is not quite ready to go. It has to flow through the lungs. And your lungs have an enzyme called angiotensin converting enzyme, which we can just call ACE. So this is another enzyme. Let me put this in a different color. Your lungs have ACE, angiotensin converting enzyme. That converts angiotensin 1 to angiotensin 2. So this is now your SpaghettiOs come out of the microwave. They're hot. They're ready to go. Now you have to get your synergistic partners. Remember, some hormones have synergistic partners. Angiotensin 2 is your active hormone. But it doesn't work alone, right? So maybe SpaghettiOs is not a whole lunch. Maybe you want to have a grilled cheese sandwich with it and something to drink. So you have to get your synergistic partners. So it's going to go to the hypothalamus, and it's going to tell the hypothalamus to stimulate the posterior pituitary to secrete ADH, antidiuretic hormone. It's also going to go to the adrenal cortex, and it's going to stimulate the adrenal cortex to secrete aldosterone. Now you have a group of 3 synergistic hormones. You have angiotensin 2, ADH, and aldosterone. Now remember, the stimulus and the effect have to match up. Our stimulus was low blood pressure or norepinephrine. So if your problem is that your blood pressure is too low, the solution is to raise the blood pressure. And whenever you have norepinephrine, if you remember that, sympathetic raises blood pressure. So they are going to act to raise blood pressure. So now that chart at the end of chapter 20 is going to come in handy. How do you raise blood pressure? Well, one thing we want to do is increase blood volume. So remember, the more blood volume you have, the more blood pressure you have. So we're going to increase blood pressure by increasing blood volume. We want more water in the blood. We can also increase resistance in your vessels. So again, reference that chart you have at the end of chapter 20, things that raise and lower blood pressure. That's what we're doing here. So our hormones are going to go to your glomerulus. So remember, this is the nephron. This is where you're making urine. They're going to constrict your afferent arteriole, and your glomerulus. So build on what you learned in chapter 24. If you do this, you will decrease your net filtration pressure. This will reduce the amount of filtrate you make, which will in turn reduce the amount of urine you make. So you are taking less water out of the blood up front. Remember that 180 liters you take out per day? You are reducing that. So this reduces the water removed from the blood. Another thing you're going to do is get more sodium potassium pumps. So down here at the end, we're going to have more sodium potassium pumps. That's what the aldosterone is going to do. These pumps, think back to chapter 24, are going to move sodium into the blood. And water follows sodium. Remember, we just talked about how sodium's main job is to attract water, maintain osmolarity. So now you have more sodium and more water in your blood. The ADH is going to give you more aquaporins. And remember, these are going to move water into your blood. So the result here of the more sodium potassium pumps and the more aquaporins is you're going to have more water return to the blood. And you're going to have less water go to the urine. So by reducing the amount of water you take out in the first place, and then by putting more of that water back into the blood, you increase your blood volume. Okay, another thing we're going to do, I'm going to go ahead and switch to another color for this, is stimulate the hypothalamus. If you remember back to chapter 13, the 7 jobs of the hypothalamus, one of those is thirst. So you're going to stimulate your hypothalamus to be thirsty. This will then cause you to drink, and when you drink, you will increase your blood volume. Then we're going to act on a blood vessel. We're going to cause vasoconstriction. And remember, ADH, when it's causing vasoconstriction, it can be called vasopressin. So vasopressin and ADH are the same thing. And when you cause vasoconstriction, you increase resistance. And increasing resistance increases blood pressure. So that is how the renin-angiotensin system is going to work to increase the amount of volume in your blood and increase the resistance in your vessels and increase blood pressure. So the effect, if we summarize it, the effect on body fluid is it increases your body fluid. Okay, then if we look at antidiuretic hormone independent of this. So ADH can be part of the renin-angiotensin system, but it doesn't always have to be. It can also be its own independent thing. So remember, ADH comes from the posterior pituitary, which is controlled by the hypothalamus. Your hypothalamus monitors your blood osmolarity. Okay, so remember, this is the concentration of salt in your blood. It's not just the amount of salt, it's the ratio of salt to water. Your hypothalamus is monitoring this. And anytime your osmolarity gets too high, so this would be like if you eat lots of salt, or if you fail to drink. That's going to increase the osmolarity. So it means your blood is too salty. it's going to stimulate your posterior pituitary to secrete ADH. So now we're looking at ADH when it's being secreted because your blood is too salty. ADH is going to cause you to have aquaporins. And remember, aquaporins are going to move water alone to your blood. So you will have more water going to your blood. You will therefore have less water in your urine. And ADH acts on water alone. It has no effect on salt. So because you're adding water, but you're not adding salt, you reduce the osmolarity. So you fix that problem of your blood being too salty. ADH is also going to come back around. We make a full circle here, and it's going to stimulate your hypothalamus to be thirsty, so that you will also add water to your blood by drinking it. And remember, ADH can also be called vasopressin because it will cause vasoconstriction. Okay, then aldosterone. So aldosterone is part of the renin-angiotensin system, but it can also act independently. Aldosterone is from the adrenal cortex. And your adrenal cortex monitors your blood potassium and sodium. If your potassium is too high or your sodium is too low, then it secretes aldosterone. So remember, the solution matches up to the problem. The problem is that your potassium's too high or your sodium's too low. Aldosterone makes your nephron have sodium-potassium pumps. These are going to put sodium into your blood. And they're going to put potassium into your urine. So they're fixing that problem. Your potassium was too high, so you're getting rid of potassium in your urine. Your sodium is too low, so you're putting sodium back into your blood. And remember also that wherever sodium goes, water follows. So whenever you have aldosterone, you gain sodium and water into your blood. You lose potassium through your urine. Then we have ANP. This is atrial natriuretic peptide. This comes from your heart. It is when your heart is overstretched by too much blood. So the problem is you have too much blood. That means you want to get rid of some of it. Well, the way you get rid of it is by having the kidneys produce more urine. So ANP, the first thing it's going to do is shut down your renin-angiotensin system. So you can imagine this as renin-angiotensin, and the foot is ANP, because it wants to do the opposite of what renin-angiotensin system does. So ANP is going to inhibit the reabsorption of sodium into the blood. So you're going to block sodium from coming back into the blood. That means you will lose sodium in the water. or in your urine. And if you lose sodium in the urine, water follows. So you're going to have more urine production. You're going to take sodium and water from your blood and lose them in the urine. You're also going to cause vasodilation. You want to reduce the resistance and get some relief on all that blood going into the heart and stretching the heart. Okay, so some things to look at here. The hormone that always goes out with its friends, that is angiotensin II. Anytime you have angiotensin II, you also get ADH and aldosterone. The hormone that reduces osmolarity is ADH because it causes you to get water alone. You don't get salt with the water. The hormone that maintains osmolarity is aldosterone because it causes you to get sodium and then water follows. So you're gaining both sodium and water in your blood. And the hormone that counteracts the other three is ANP. So it's kind of notice all these hormones start with an A. You have angiotensin II, antidiuretic hormone, aldosterone, and atrial natriuretic peptide. Three of them are all doing the same thing. Angiotensin, ADH, and aldosterone are all increasing the amount of blood volume and blood pressure. ANP does the opposite. It reduces the blood volume and blood pressure. And if you eat a bag of chips while sweating on a hot summer day, which hormone will you get? Well, think about chips are salty, so you are adding salt to your blood. When you sweat, you lose both water and salt, but you lose more water. Sweat is mostly water with a tiny bit of salt. So if you're eating chips and sweating, you are increasing your blood osmolarity. And remember, your hypothalamus will detect this, and it will stimulate your posterior pituitary to secrete ADH. ADH will give you aquaporins. You will reabsorb water alone. ADH will also go back and stimulate the hypothalamus to be thirsty, and you'll drink some water.